Welcome, everybody. In this episode, we take a look at the 4 pitfalls to AI ethics and are they solvable?
Welcome to ClickAI Radio, where you'll learn the secrets to transforming your small to medium business. Grant has been helping businesses transform using technology for over 30 years. Advanced technologies like artificial intelligence have been available only to large companies and advanced technical teams. Grant will discuss how you can use to leverage AI and other technologies to grow your small to medium business. As a gift, Grant is offering his ebook, AI for Sales Growth, at clickairadio.com. Now, here's your host and biz tech geek, Grant Larson.
Okay, hey everybody, welcome to another episode of ClickAI Radio. So glad to have in the house today, Plainsight AI. What a privilege. Elizabeth Spears with us here today. Hi, Elizabeth.
Hey, Grant. Thanks for having me back. Happy to be here.
Thanks for coming back. You know, when we were talking last time, you threw out this wonderful topic around pitfalls around AI ethics. And it's such a common sort of drop phrase. Everyone's like, oh, there's ethics issues around AI. Let's shy away from it. Therefore, it's got a problem, right? And I loved how you came back. And it was after our episode, it's like you pulled me aside in the hallway, metaphorically, like, Grant, let's have a topic on the pitfalls around some of these ethical topics here. So you hooked me. I was like, oh, perfect. That's a wonderful idea with that. So typically,
yeah, I think there's so many sort of high level conversations about ethics in AI, but I feel like we don't dig into the details very often of kind of when that happens and how to deal with it. And like you said, it's kind of the common pitfalls.
It is. And, you know, it's interesting is in the AI world in particular, it seems like so many of the ethical arguments come up around the image style of AI, right? Ways in which people have misused or abused AI, right? For either bad use cases or other sort of secret or bad approaches. So this is like, you're the perfect person to talk about this and cast the dagger in the heart of some of these mythical ethical things, or maybe not, right? All right. So
yeah.
Yeah. All right. So let's talk through some of these. So common pitfalls. So there were 4 areas that you and I sort of bantered about. You came back and you said, okay, let's talk about bias. Let's talk about inaccuracy in models. Let's talk about fraud. And then perhaps something around legal or ethical consent violations. Those were 4 that we started with. We don't have to stay on those, but let's tee up bias. Let's talk about ethical problems around bias. All right. What are your thoughts?
So, I mean, there's several types of bias and often the bias and inaccuracies can kind of conflate because they can sort of cause each other. But I have some examples of both. And then again, some where it's really bias and inaccuracies that are happening. Mm-hmm. But one example or one type is not modeling your problem correctly, and in particular, too simply. So I'll start with the example. So you want to detect safety in a crosswalk, right? Relatively simple kind of thing. Mm-hmm. And you want to make sure that no one is sitting in this crosswalk, because that would generally be a problem.
That's a problem. Yep.
So you do body pose detection, right? And if you aren't thinking about this problem holistically, you say, all right, I'm going to do sitting versus standing. Now, the problem with that is, what about a person in a wheelchair? Mm-hmm. So then you would be detecting kind of a perceived problem because you think someone's sitting in the middle of a crosswalk, but it's really just about accurately defining that problem, and then making sure that's reflected in your labeling process. And that kind of flows into another whole set of problems, which is when your test data and your kind of labeling process are a mismatch with your production environment. Mm-hmm. So one of the things that we really encourage for our customers is collecting as much production as close to possible, or ideally just production data that you'll be running your models on, instead of having sort of these very different test data sets that then you'll kind of deploy into production, and there can be these mismatches. And so sometimes that's a really difficult thing to accomplish.
Yeah, so I was going to ask you on that. In the world of generative AI, where that's becoming more and more of a thing, and the appetite for sort of generating or producing that test data, is the premise that, because I've heard some argue, wait, generative AI actually helps me to overcome and avoid some of the bias issues, but it sounds like you might be proposing just the opposite.
It actually works both ways. So creating synthetic data can really help when you want to avoid data bias and you don't have enough production data to do that well. Mm-hmm. And so you can do you can do that in a number of different ways. Data augmentation is one way. So taking your original data and, say, flipping it, or changing the colors in it, et cetera. So taking an original data set and trying to make it more diverse and kind of cover more cases than you maybe would originally, to make your model more robust. Another kind of way of doing that is synthetic data creation. So an example there would be you have a 3D environment in one of these, game engine type things like Unreal or Blender. There's a few, and you have, say, I want to detect something in it's usually in a residential setting, right? So you can have a whole environment of different, housing types, and it would be really hard to get that data, without having generated it, right? Because you don't have cameras in everybody's houses.
Right.
So in those cases, what we encourage is pilots. So you, before really, deploying this thing and letting it free in the world, you use that synthetic data, but then you make sure that you're piloting that in your real world setting as long as possible to, suss out any issues that you might come across.
So let's go back to that first example you shared, where you got the crosswalk, you have the pedestrians, and now you need to make sure you've got different poses, like you said, someone, sitting down on the road or laying on the road. Certainly using generative AI to create different postures of those. But what about, the introduction of something brand new, such as, like you said, the wheelchair or some other sort of foreign object? Is the generative AI going to help you solve for that, or do you need to lead it a bit?
It absolutely can, right? So it's basically anything that you can model in a 3D environment. And so you can definitely model someone in a wheelchair in a 3D environment. And Tesla uses this method really often because it's hard to simulate every kind of crash scenario, right? It's hard to have real data from every kind of crash scenario. Mm-hmm. And so they're trying to model their problem as robustly as possible. And so in some of those cases, they are like, all of these types of things could happen. Let's get more data around that. The most efficient and kind of most possible way of doing that is with synthetic data.
Mm-hmm. Awesome. Okay, so that's a key approach for addressing this bias problem. Are there any other techniques besides this generative, training data approach? What else could you use to overcome the bias?
Yeah. So another type kind of is when you have, like I was saying, a mismatch in test and production data. So and a lot of people, even, computer vision people, sometimes don't know how much this matters when it's things like, for example, working with a live video. So in those cases, bitrate matters, FPS matters, your resizing algorithm and your image encoding. And so you'll have, in many cases, you're collecting data in the first place for your test data differently than it's going to run in production. And people can forget about that. And so this is a place where, having a platform like Plainsight can really help, because that process is standardized, right? So the way you're pulling in that data, that is the same data that you're labeling, and it's the same data that you're then, inferencing on, because you're pulling live data from those cameras, and it's all managed in one place end to end. So that's another strategy. And another thing that happens is, when there are researchers that will be working on a model for like 2 years, right? And they have this corpus of test data, right? But something happens in the meantime, right? So it's like phone imaging has advanced in that time. So then your input is a little different, or like the factory that they were trying to model, the floor layout changed, right? And they didn't totally realize that the model had somewhat memorized that floor layout. And so you'll get these problems where you have this, what you think is a really robust model, you drop it into production and you don't know you have a problem until you drop it into production. So that's another reason that we really emphasize having pilots, and then also having a lot of different perspectives on vetting those pilots, right? So ideally you can find a subject matter expert in the area outside of your company to, take a look at your data and what's coming out of it. And you have kind of a group of people really thinking deeply about, the consistency of your data, how you're modeling your problem, and making sure that kind of all of those things are covered.
Well, and reducing cycle time from this initial set of training to sort of validation of that pilot is crucial to this, because as you're pointing out, even if you keep that cycle time short and you do lots of iterations on it, some assumptions may change. How do you help? What's the techniques for keeping someone looking at those assumptions? Like you said, maybe it's a change in camera phone technology, or it's a change of the layout. Like I said, as technology people, lots of times we get so focused on, we're just pushing towards the solution, we sort of forget that part. How do you get someone? Is that just a cultural thing? Is it a AI engineering thing that someone's got a role in the process to do that?
I think it's both. So I think the first thing is organizations really need to think deeply about their process for computer vision and AI, right? And some of the things that I've already mentioned need to be part of that process, right? So you want to research your users in advance, or your use cases in advance, and try to think through that full problem set holistically. You want to be really, really clear about your labeling, right? So you can introduce bias just through your labeling process. If the
humans themselves are introducing it, right?
Exactly. If you have some people labeling something a little bit differently than other people. So like on the edge of an image, if you have a person on the edge, do you count that as a person, or is it, or as another person, or is it not counted? How far in the view do they have to be? So there's a lot of gray area where you really just need to be very familiar with your data and be really clear as a company on how you're going to process that.
So there's labeling boundaries, but then backing up, there's the label ontology or taxonomy itself, right? Which is that itself could just be introducing bias also, right?
Yeah. And then back to kind of what we were saying about how to really think through some of these problems, is you can also make sure that as a company, you have a process where you have multiple passes on that annotated data, and then multiple passes on the actual inference data, right? So you have a process where you're really checking. Another thing that we've talked about internally recently is, we have a pipeline for deploying your computer vision. And one of the things that can be really, really important in a lot of these cases is making sure that there is a human in the loop, that there is some human supervision, to make sure that you aren't surfacing bias that you didn't anticipate, or your model hasn't drifted over time, things like that. And so something we've considered is being able to kick off just in that process, have it built in that you can kick off a human, like a task for a person, right? So it's just built in. And so it no matter what you do that thing.
Is this as a governance function? Is that what you're getting at then?
Kind of. So it's like a processing pipeline for your data. And so you can have things like, all right, at this step, I'm going to augment my data. And at this step, I'm going to, run an inference on it or flip it or whatever it is. Right. And so in that, you could make sure that you kick off a task for a human to check. Right. Or whatever the case may be. So there's several.
So good process maturity is another technique for how do we help to overcome bias as well as inaccurate models. And I'm assuming you're almost bundling both of those into that, right? It's really both, right? Yep.
And like you said, the another way is reducing that time, and also making sure that you're working on production data whenever possible. So reducing this is where the platform can help as well, because when you aren't off in research land without production data for 2 years, but you have a system where it makes it really easy to connect cameras and just work on real production data, then two things: you're reducing the time that it takes to kind of go full circle on labeling and training and testing, and then also you have it all in one place. And that's one of the problems that we solve, right? Because in many cases, computer vision engineers or data scientists, they're kind of working they don't have the full pipeline to work on the problem. So they have this test data set and they're working on it somewhat separately from where it will be deployed in production. And so we try to join those two things.
Yeah, I think that's one of the real strengths of the platform, of your platform, the Plainsight platform, is this reduction of the cycle so that I can actually be testing and validating against production scenarios, and then take that feedback and then augmenting that with the great governance processes that you talked about. Both of those are critical. Let's pivot and talk about fraud. As you know, certainly in computer vision, holy smokes, fraud has been probably one of the key areas that the bad guys have gone after, right? All right, what can you do to overcome this and deal with this?
It can really become a cat and mouse game. And I think the conversation about fraud boils down to it's not clear. It boils down to, is it better than the alternative, right? So it's not clear that just because there could be some fraud in the computer vision solution, it may or may not be true that there could be more fraud in another solution, right? So the example is, technically, you used to be able to, and I think with some phones you still can, 3D print a face to defraud your facial detection to unlock your phone.
Yep.
And so then they've, done a lot of things, advancements. So this is harder to do, which, like, there's a liveliness detector. I think they use your eyes for that. And then, there's a few, but you could still use a mask. So again, it's this cat and mouse game. And another place is there are models that can understand text to speech. And then there are models that you can put on top of that that can make that speech sound like other voices, right? So the big category here is deep fakes. But it's, you can make your voice sound like someone else's voice. And there are banks and other things like that use voice as a method for authentication.
Right. I'm sure we've all seen the Google Duplex demo or scenarios, right? That was a few years ago now, right? But I mean, that technology obviously continues to mature.
Exactly. And so then the question is, okay, if I can 3D print a face or a mask and unlock someone's phone, is that harder than actually someone just finding my 4 to 6 digit phone numerical code to unlock my phone? So I think there it really becomes a balance of which thing is harder to defraud. And in fraud in general, if you think about cybersecurity and everywhere that you're trying to combat this, it's a cat and mouse game, right? People are getting, people figure out the vulnerabilities in what exists, and then people have to get better at defending it. So
the argument is, if I can say back to you, the argument is, yeah, it exists, but hey, how is this different from so many other technologies or techniques where, again, you got fraudsters trying to break in? And this is just part of the business today, right? It's where it is.
I think it becomes an evaluation of, does it cause more or less of a fraud problem? And then it's really just about evaluating the use of technology on an even plane, right? So it's not about should you use AI because it causes fraud. It's should you use any particular method or technology because there's a fraud issue, and what's going to cause the least fraud,
right,
in your specific use case. Yeah.
Yep. Okay. Yeah. So fraud. So you and I had talked about some potential techniques out there, like there's Facebook, Instagram technology algorithm, right? I think it's called Seer. I think it came out not too long ago. It's an ultra large vision model. It takes in more than 1 billion variables. Can you believe that? That's a lot. It's a massive model. I mean, I've built some AI models, but not with 1 billion images. That's incredible. So, are you familiar with that? Have you looked into that at all? Seer itself?
Yeah. So this basically this method where you can look basically to try to address bias through distorting of images.
Mm-hmm. Yeah.
Yeah. So I can give you a good example of something that actually we've worked on. I'm going to change the case a little bit to kind of anonymize it. But so in a lab setting, we were working on some special imaging to detect whether there was a bacteria in samples or not, right? And in this case, we were collecting samples from many labs across the country. And one thing that could be different in them was the color of kind of the substrate that the sample was just in. It was essentially a preservative.
Wow.
And so, but there were a few different colors and they were used kind of widely. And so it wasn't generally thought that, this would be a problem. But so the model was built and all the data was processed, and there was a really high accuracy. But what happened and what they found out was that there was a correlation with the color and whether the bacteria was present or not. And it was just a kind of a chance correlation, right? But if you had something like that image distortion, so if you took the color out automatically or you messed with the color, then that would have taken that bias out of that model. Mm-hmm. And then as a second thing happened, actually, which was when the people in the lab were taking the samples out of the freezer, they would take all of them out at once, and they were just kind of ordered. And so they would do all of the positives first and all of the negatives second. And machine learning is it's a really amazing pattern detector, right?
Yeah.
Like that is what it is.
What it's about. Yep.
And so again, they were finding a correlation just between whether it was more thawed or not. And that was correlating with whether it was positive or not. So, some of this really comes back to what you learn in science fair and putting together a really robust scientific method and making sure you're handling all of your variables really carefully and clearly, and you know what's going into your model, and you can control for that as much as possible. So that Facebook method is can be really valuable in a lot of cases to suss out some of these correlations that you may just not know are there.
Yeah, I think what's cool is they've open sourced it, right? I think it's called Swav, SWAV. Which is awesome. They figured that out and made that open source so that obviously the larger community needs something like this to, of course, help deal with some of this bias challenge. Interesting.
Yeah.
Okay, that's cool. So, all right, I really wanted to ask you about your thoughts on that approach. So I'm glad to hear you validate that. Yeah.
No, it's great. I mean, there really has to be a process, especially in a model like that, where you try to break it in any possible way that you can, right? There has to be a whole separate process where you think through any variable that there could be. And so if there's a model that has, so many just out of the box, that's a great place to start.
Yeah. Awesome. Okay. And then the last category here around ethical violations. Any thoughts on that, addressing that, overcoming that?
I think that really just comes down to when you need permission to be doing something, you need to make sure that you're doing it, right? Or you're getting it. And that, obviously that happens in cases where there's facial recognition and making sure that people know that that's going on. And that's similar to being kind of videotaped at all, right? And so that one's fairly straightforward. But sometimes people need to, when you're putting together your ethics position, you need to make sure that you're really remembering that that's there and you're checking every single time that you don't have an issue. Yeah,
permissions. And there's this notion, I'll come up with a term, it feels like permission creep, right? It's kind of like scope creep, right? It's like, well, you may have gotten permission to do this part of it, but you kind of find yourself also using the data or stuff over here, right? To maybe solve other problems. And that's a problem in some people's minds for sure. There's various
articles. That's a really good point.
Yeah, various articles, people out there talk about that part of it sort of creeping along. And how do you help ensure that what it is I gave you the data for, or what we're using it for, is just for its, permitted intended purpose, right? That's always a challenge for sure. Okay, so you've been more than fair with your time here today with us, Elizabeth. Can you draw any conclusions? What's the top secret answer to the overcoming the 4 pitfalls here of AI ethical?
So one thing I have to add, we would be remiss if we didn't talk about data bias without talking about data diversity and data balance, right? So, obviously the simple example there is fruit. So if you are looking at, if you have a data set with 7 apples, 1 banana, and 7 oranges, it's going to be worse at detecting the banana. But the more real world example that happens is in hospitals, right? So in the healthcare system in general, we have a problem with being able to share data, even anonymized data. So when a hospital is building a model, there have been problems where it can be they have bias in their data set, right? So in a certain location, you can have something like if you're coming in with a cough in one area, it may be most likely that you have a cold, but in another area, it may be more accurate to start evaluating for asthma, right? So that kind of thing can come up. So if you take a model that's done in one hospital and try to apply it elsewhere, then again, that's a place where you can run into problems.
Is that kind of like a form of confirmation bias, meaning, you have the same symptom, but you come into two different parts of the hospital and, well, this person's coughing and, you're in the respiratory area. So they immediately think it's one thing, but now you go into another part of the hospital and, well, yeah, a cough is a symptom for that too. Suddenly, that's what they think you have. It's kind of,
that's a great point. It's sort of the machine learning version of that.
Yeah, that's right. Yeah, it's a confirmation bias sort of view. It's like, this is but how many variables does it take for you to actually have true confirmation, right? Well, with this example from Facebook, 1 billion, but how many do you need to have?
I think it's less about the variables and it's more about your data balance and making sure that you're training on the same data that's going to be used in production. So, it's less of a problem if you are, only deploying that model at one hospital. But if you want to deploy it elsewhere, you need data from everywhere, right? Or wherever you're planning to deploy it. So again, it really comes back to that data balance and making sure your test data and your production data are kind of in line.
Are there any of these ethical biases we've talked about that are not solvable?
That's a good question. I think, that maybe
that's a good answer. That's a safe answer. Are you running for politics? Are you running for political office?
I think there are definitely some that can be really hard. So something that we touched on, you talked about, is there inherently our supervised models inherently more biased than unsupervised? And like the answer there is probably yes, because a human is explicitly teaching a model what's important in that image. And so, that thing can be exactly what you're looking for, right? You want to make sure there's not a safety issue or whatever it is, but just it's a human process. So there can be things there that you don't catch.
Yeah. That's been a question on my mind for a while, which is the implicit impact of bias on supervised versus non-supervised. I work with another group called Able. Have you run into Able? They're one of the auto ML providers out there, and more on sort of the predictive analytics side of AI, right? They're not doing anything with computer vision. They have this capability where they'll look at, but it's always supervised data. But the problem they're trying to solve is, okay, got a lot of data. Just give me tone, give me signal. In other words, before I spend too much time trying to, do some training and guiding the model, just do a quick look into that data set and tell me, is there any tone or signal where these particular supervised elements, they can draw early correlation to outcome or predictive capabilities? And the idea is that as the world of data keeps getting larger and larger, our time as humans doesn't keep getting larger and larger. So we need to reduce what's the total set of stuff we're looking at, dismiss these other pieces. They're irrelevant to being predictive, and then you can focus on the things that are important. Anything like that in the computer vision world?
So unsupervised learning is less common in computer vision, but one of the things that can happen is just the data that exists in the world is bias, right? So an example is, say you want to predict what a human might do at any one time, and you want to use an unsupervised method for this. So say you want to scrape the internet of videos. If you look at the videos on YouTube, the videos that people upload are inherently biased. So if you look at security videos, they're like almost all fights, right? So your model, because that's what humans think is interesting and is, uploaded in a security video. And so, I mean, not almost all, but a lot of them, right? It's inherently what humans think are interesting. And so there are places like that where just inherently your data set is kind of biased because we're human. Mm-hmm. So again, it's another place that you have to be pretty careful.
Yeah. Okay. So sounds like the problems are, I'm doing air quotes. These are solvable, but it takes some discipline and rigor. To I think so. These. Yeah. Okay.
And it's just so important for organizations to kind of sit down and really think through their ethical use of AI and how they're going to approach that and get a policy together and make sure they're really kind of living those policies.
Excellent. Okay, Elizabeth, thank you for your time today. Any final comments? Any parting shots?
No, I think I appreciate you having me on. That was a really fun conversation, and I always enjoy chatting with you.
Likewise, Elizabeth, thank you for your time. Thank you everyone for joining in this episode. Until next time, get some ethics for your AI.
Thank you for joining Grant on ClickAI Radio. Don't forget to subscribe and leave feedback. And remember to download your free ebook. Visit clickairadio.com now.